I don't think that works anymore.
No, you ruined my life.
Okay, tomorrow we're gonna do rectangular rule because I just realized we have questions on that, and yeah, we'll do that.
Make those erotic donuts again.
Oh my god, I still have pictures of them.
Did he say erotic donuts? Oh, oh.
Do you know what the funny thing is? I have like this little memory box, and I put the card you guys gave me in my memory box.
No.
Oh.
And the Krispy Kreme hat.
Yeah. There's our creepy pictures.
Yeah, they're in there as well.
Yes.
Yes.
We're in Mass's time capsule.
Your children will look into your memory.
They're just gonna see our faces. Like, who the hell are these? Hello, little. No, stop.
What can we do in hashing tomorrow?
I have no idea. I don't like that question at all. I looked at that 2012 one.
Hashing?
Yeah.
Hash tables? Is that the hash tables?
Yeah, but
yeah.
Isn't there like different things we have to do?
I've had a go at it, but like I got it wrong because I don't know. It's weird. Like.
Are you guys going to go library anytime soon?
Huh?
The what?
You guys going to go library?
Nope. I'm not leaving home.
To go, to be honest.
I like home. Home is good. Home is
home
where
good.
Wi-Fi is at.
No, because at home all I do is sit and eat. It's not really like.
Is that what you're doing now?
Yeah.
Yeah. She sent me a picture of like a box of whatever that was and ate the whole thing.
I actually just had pasta and Coke and Roches.
She had Coke.
Disgusting. Disgusting mess.
Disgusting.
It was actually very nice.
It sounded very nice.
Okay.
I'm hungry.
So do you guys have any things for tomorrow?
Let's do the complexity, second, and Newton-Raphson tomorrow.
No. We're probably going to do all the three methods tomorrow. I know,
we'll
but...
do the complexity and then do secant and Newton-Raphson tomorrow.
Complexity.
Or keep going until Sunday.
I can't do tomorrow, or I can't do Saturday.
Why not?
I can't do Saturday and Sunday.
Saturday is my dad's birthday, and I'm out tomorrow.
Oh, so. Happy birthday!
Yeah, he's 50.
Happy birthday to Mr. Perkins.
Isn't that Saturday?
To Mr. Perkins.
Yeah, Saturday, he's 50.
So why are they singing it now? Guys, bad luck.
They're not going to talk with it.
Gosh.
Is it bad luck? What?
Yeah, bad luck to say happy birthday before the day.
Let us all go to Nathan's house.
Yeah, I know where he lives. Does anyone want his address?
I'm staying I'm... Shut up.
He lives in Aubrey. If anyone would like his door number. Well, you're just dying. You better be. So, if you want his postcode...
I think it's 64.
Go, Mass, quickly. Quickly, Mass.
Right, so tomorrow... Wait, are we not doing... You're not doing bisection method? Oh, you are, sorry. Yeah, it just changed. Rectangular rule, secant, Newton, bisection, hash tables.
We're probably not going to go through everything, because all the three methods are going to take ages.
That I do not appreciate that. That was... Oh my god!
Gandhi Nukes 2014.
Nathan's going to get internet people at his house now.
No!
Why is he hyperventilating?
Gandhi Nukes! He's back!
Oh.
Guys. Guys. Who is Gandhi Nukes?
He got banned already. Who banned him?
Oh, thank you. Thank you. It wasn't me, it was Sam.
Samuel. Stop banning people, Samuel.
Well, you know, he's causing problems.
Yeah.
That guy.
Okay, let's just do complexity then. I'm not going to go through a lot on it, by the way, because there is a lot to go through. Get my notes. Okay, so
Should do a nested example, I guess.
You know you're not gonna do all of them tomorrow, right?
yeah, I know. Because I'm pretty sure
Okay.
the
I
method.
love how hash tables is last.
What can I do?
Can you make hash tables first?
No. We have to
Please.
go for rectangular rule because we already went for trapezium and Simpsons. And that's one of the rules we have to know. We have to know a lot for this exam. God.
So much corruption.
Okay, I'm gonna put a star next to the things I have to revise for tomorrow. Because I'm revising before the stream. So rectangular rule. I have no clue about hash tables. That's why I'm gonna do it last.
Are they like hash browns? Because I like hash browns.
You're not making me
Tasty.
hungry, you know that? Because I haven't
Yeah, hash
eaten.
browns are alright.
I'm really hungry, so
Because you're fat.
No.
I haven't eaten today. Oh, I have eaten today. Shut up, Mez.
It could have been eaten in the background.
Yeah,
Not
but that's
really.
rude. That's
That's
really
not
rude.
rude. I put myself on mute so none of you guys can hear me.
Yeah, that's fine. But when you don't, okay.
But I did it.
I didn't. And
Yeah, I know. I heard it, and it was disgusting, Matthew.
What?
Well, none of you said anything, so I just kept going.
I ate some pistachio nuts, but I'm still hungry.
Why does
Is that
everyone
your
have
nuts,
food
Logan?
but me?
How could you pistachio nuts? Are you not allergic to those?
No. No.
Yeah, that makes a lot of sense. I'm allergic to nuts, but I
Just
can have
peanuts.
pistachio nuts.
No, just peanuts.
So say you're allergic to peanuts.
Okay.
I don't know if I'm just peanuts.
I do
But
say I'm
Ferrero
allergic
Rochers
to
are
peanuts.
hazelnut.
Oh, well, then I've been missing out my whole life.
You idiot.
Shut up.
Oh, we haven't done
Apparently,
regression. Well,
Yeah.
regression sounds like a topic we'll do on I don't know, whenever we can.
I just saw Dan's comment on the chat.
You sound like a horse when you eat.
You do.
Really?
Well, not in
Yeah.
a bad way.
I don't. You can't. A horse
Echo.
is far.
Echo,
Echo.
echo, echo, echo.
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 Echo. Echo. Echo.
Okay, let's do the thing we're doing.
Regressiones.
No regression, we're doing complexity. Complexity.
Be right back.
You were writing it out. Alright, complexity.
Yes, complexity. Revision questions. That'll be question 1 from the revision questions. Okay, let's do this. Okay, question 1. There. Whoa, okay, this looks very bad. Am I still here? Hello?
Hello.
Oh,
Hi.
don't go quiet, because I've never. That's the only way I
Alright,
know.
I'll go with the complexity with you then. So,
You don't
what
have.
kind of algorithm are we doing?
We're not doing an algorithm. Oh,
Well,
well,
aren't you trying to find the complexity of an algorithm?
yeah. Okay, so the question is, what is a computational in terms of n? Okay, so the first thing we've got to make sure we know is what kind of answer we should give, and it tells us in terms of n. So it has to be something with n in it. Okay, now another thing we need to know is that a loop is always 1 plus 2 n. And why is that? Because it's 1 initialization plus n for the amount of times it's run, and another n for the amount of times it's iterated. So it'll add 1 every time. So that's why it's an n. It will be a 1 all the time. It goes through the loop. That's why.
Yeah, this is when we're including the loop cost, or the cost of the loop process.
Yeah, you can call it that.
So if you don't include the loop process, then you wouldn't put the 1 plus 2n.
Yeah, I'm doing part 2 because there's no point in doing part 1. It's the same thing except you don't count the loops. So whenever you have,
I'm just letting them know, innit?
yeah, no, and I'm letting them know as well. Okay. Now for the second loop, because it's a loop inside of a loop, you must times that loop by n first. So it'll be n times 1 plus 2n. Is Nathan back?
I am.
I heard your breathing.
He sounds like I was singing.
So that will be 2n squared, because it's n times 2n, so it'll be n times 2n is the same as n times 2 times n. That's why it's 2n squared, for the ones that don't know algebra. Alright, so yeah, plus n.
I should be paying attention.
Okay, so that's one of the things we have to do, and then because this loop has a constant, we have to add 1, so that's 1. That's basically it. So every time the loop runs, you add 1. No, it's not 1, it's n, sorry. The constant inside is an n. And it's because it's run n times, it should be n squared. Yeah, because it's n times n. So n times n squared. Okay, you can get that from the notes as well. Let me try and find the 4 loops. Okay, time complexity 4 loops. There it is. So if it's a constant inside the loop, it will be n times n, because the constant is n. Yeah, it says on the notes. If you have the notes, if you don't, you can download it from the CMS group page. So total time, the constant is times by n, so it will be n, essentially. Okay, let's go back to where we were. Okay, now there's another loop, and that loop is inside of a loop that is inside of another loop. So that means the loop will be
loopception.
n. Yeah, loopception times n times 1 plus 2n, which is the same as n squared times 1 plus 2n, which is 2n cubed plus n squared. And yeah, that's it. Okay, now for this one here, the constant is being looped in 3 loops, so that means each of them will be n cubed. So this will be an n cubed constant. The thing is, on this line, there's 3 things happening. You're multiplying, so 1, and then you're adding that value, 2, and then you're setting that value to that variable, to that multi-dimensional array. So that'll be 3 times, so it'll be n cubed, not there, on the equal sign, so n cubed, n cubed, n cubed, and then you just add them together, and then you get 3n cubed. Now, to get the answer that includes the cost of the loop process, you do, what can I do to make it equal? Let's just put result. So we put r equals to, so the first loop, 1 plus 2n, and if I were you, I'll put everything in brackets, so just so you know what you're doing. Then you do plus n, 1 plus 2n, plus, I could have just put 2n squared, but anyways, and then n squared, and then plus 2n cubed plus n squared plus 3n cubed.